This chart shows Anthropic's internal benchmark comparing a single Claude Opus agent against a multi-agent orchestrator. The multi-agent setup outperformed the single agent by 90.2%. That gain was recorded on breadth-first research queries, a real number from a real production environment. Yet, if you open Anthropic's own engineering guide, the authors explicitly tell builders to avoid exactly what they just did. Their documentation warns developers to start with the simplest single-agent solution possible, adding complexity only when absolutely needed. Here is the core contradiction. If swarms are mathematically superior, why do the model creators explicitly tell you not to build them? I'm Bearded AI Guy. On this channel, we break down AI system architecture without the hype. By the end of this video, you will have a strict 3-tier decision matrix that tells you exactly when a workload requires a single agent and when it demands a swarm. Making the wrong choice here dictates whether your engineering team ships a maintainable, scalable product or burns through runway maintaining expensive cosplay. Builders navigating the modern AI stack eventually hit a fork in the road. They must commit to one of two highly distinct architectural paths. The first path is the capable agent with skills. In this setup, one lead agent loop maintains complete authority. Specialized behaviors, tools, and prompts are packaged into files. They remain entirely inert on the hard drive until explicitly loaded into context. The second path is the true swarm. A swarm operates with multiple independent agent loops running concurrently. Each of these loops acts as an active, independent decision-making unit at the exact same time. To prevent concurrent loops from stepping on each other, swarms require explicit external mechanisms like shared memory namespaces, robust message passing, and durable task trackers. This boundary dictates exactly where the application stores its state, how expensive execution becomes, and exactly how the system will fail in production. To see the extreme end of the swarm architecture, look at the framework Ruflo. Ruflo abandons the idea of a simple AI assistant. It treats large language model orchestration exactly like a traditional distributed microservices backend. This chart shows the Ruflo stack. The system relies on deep technical routing layers to manage communication across specialized roles. The topology layer is highly flexible, supporting network shapes like hierarchical trees, star formations, or fully connected meshes. When dozens of autonomous agents operate at once, they inevitably disagree on a task state. Resolving that requires a formal consensus protocol. Ruflo pulls these protocols directly from distributed systems engineering. It forces agents to agree using Raft, Byzantine fault tolerance, or gossip protocols. This creates massive financial and computational overhead. Every additional agent demands another isolated context window, another set of parallel API calls, and constant data synchronization just to maintain network health. You only absorb that immense overhead if complex coordination itself is the primary engineering challenge of your product. Anthropic takes the opposite approach. They borrow a classic software engineering principle: build the monolith first. Their escalation model starts with Tier 1, skills. These procedural instructions sit idle on the disk until invoked, requiring zero coordination cost. The lead agent simply grabs the procedure, executes it, and moves on. Tier 2 escalates to subagents, a context isolation primitive. If sifting through thousands of log lines would break the main agent's context, a subagent isolates that work, returns a single condensed summary, and then deletes itself. Tier 3 is agent teams. This is the absolute architectural threshold, where independent, long-running sessions finally establish permanent communication lines with one another. Anthropic's framework positions communicating agents as a severe architectural escalation. It is a boundary you only cross when the underlying task forces your hand. You can verify a system's true underlying architecture simply by watching how it breaks under heavy production load. A capable agent architecture fails through serial overload. A single context window becomes saturated with code, traces, and reasoning until it exhausts its limit. When a model suffers context exhaustion midway through implementation, it frequently hallucinates. It surveys a half-finished repository and confidently declares the job is complete. Swarm architectures break in entirely different ways. The first major point of failure is a delegation miss, where the lead loop refuses to hand off specialized work, trying to do everything in line and ignoring its sub-agents entirely. Then you encounter coordination drift. This occurs when highly complex networks of agents fail to synchronize their internal state. Symptoms include orphan processes spinning indefinitely, parallel workers duplicating the exact task, and crashes from simple plumbing failures. AI context exhaustion looks nothing like a distributed network failure. Because the failure shapes never overlap, the architectural fork between them is absolute. We can formalize Anthropic's logic into a strict 3-tier decision matrix for your own stack. Rule 1. If the task relies entirely on standard procedural knowledge, you stay at Tier 1 and use simple skills. Rule 2. If your engineering obstacle is isolating heavy, noisy data from the main reasoning thread, you escalate to Tier 2 and spawn subagents. Rule 3. You escalate to a Tier 3 swarm only when the task demands separate trust boundaries, discrete task ownership, or parallel search. This resolves the paradox we started with. Anthropic achieved a 90.2% success rate specifically on open-ended breadth-first queries. A breadth-first query is the exact definition of a parallel search workload. In that scenario, the computational overhead of a swarm becomes a profitable trade-off. The core axiom of the agent era comes down to this: agency is cheap, coordination is not. Spinning up another AI agent is a simple API call. Managing the precise state, memory, and task handoffs between them is what actually breaks your system. The smartest teams in enterprise engineering are rapidly converging on this monolith-first mindset, deferring coordination logic until they absolutely have to write it. Subscribe to the channel and drop a comment below letting me know which of the 3 tiers your current workload actually requires in production. In the next episode, we look at what happens when you follow these rules, but the system still fails. We will examine why the raw reasoning power of the model is rarely the true bottleneck. Most of the time, the real failure lies in the interfaces and the rigid tool designs we force the agents to use. Build the lead agent first, earn the second one through necessity, and only adopt the complexity of a swarm when the shape of the task leaves you with no other choice.